the previous video, our team introduced where the modules used in Habitat 67 were produced, compared the construction period and cost between the production site and the construction site, and explained the process of making unit modules. Also, we mentioned that the installation of various essential facilities such as bathrooms and kitchens was carried out concurrently with the fabrication of the modules. Recognizing the insufficiency of that explanation, we will provide a quick supplementary explanation before starting the video. Within Habitat's building budget of $13.5 million, a precast concrete factory was erected on the site in order to cast the modular boxes along with other building components such as pedestrian streets, elevator cores, and access stairs. Simultaneously, additional prefabricated components were manufactured off-site, such as fiberglass bathroom units and pre-assembled kitchens.
And this is the first time you're seeing one of the molded bathrooms. These are the famous fiberglass bathrooms. They would drop the bathrooms in and then pour the cement for the roof. So all this is molded. As you've seen in the last 10, 15 years where you can go to a hardware store and you can buy a molded bathroom. So he was ahead of his time, fiberglass.
These components were delivered to the site and installed in the prefabricated modules before being hoisted into place by crane. Once in place, boxes were connected to each other by post-tensioning, rows, cables, and welding. The boxes, pedestrian streets, and elevator stair towers formed the three structural elements of the building. They were connected together to form a continuous, integrated three-dimensional structure, or participating as load-carrying members. With this, we will conclude the summary of last week's video and provide explanations for the lacking parts. In this presentation, we will discuss the structure and design of Habitat 67. Firstly, we will examine how Habitat 67 is organized overall and why the building appears to be stacked with similar blocks. We will also explore how Habitat 67 was produced, including the technologies and methods used in its production process. Finally, we will delve into how the design of the Habitat 67 was conceived from the perspective of the user and what impact it has. Through these discussions, we aim to provide interesting insights into unique structure and design of Habitat 67. Habitat 67 is made of 354 pre-manufactured concrete boxes stacked in arrangements that create living units out of each box, or when they overlap multiple boxes connected together. This also has the overall effect of the building looking like a pile of blocks that a toddler might leave on the carpet at home. But there is a very clear and strict order to this arrangement. It's a series of clustered spirals. On the back side are walkways and a series of elevator towers. These connect the larger terraces that are shelled for studio units. Elevator shafts were built by assembling precast units one above the other. At the level of each walkway, the elevator's concrete encasing was used to anchor the large walkway slabs down. While it may seem haphazard at a local level, when you zoom out, the designers repeated around elevator towers and walkways. Each unit is made like it looks as a separate 56 square meter concrete box pre-made and a special factory nearby. They even finished the interiors on the ground with bathrooms, kitchens, and all. The bathroom was made by another company out of wrapped gel-coated fiberglass, like a boat. Once altogether, a crane lifted the entire thing into place. This is interesting, because in one sense this is an efficient and simple method of constructing. There's no separate structure frame, for instance. Each box was precast separately and conceived as a self-contained entity with complete visual and acoustical privacy due to the doubling of walls and floors occasioned by the placing of adjacent modules. They were able to engineer that out of earlier iterations. The final design has each block holding up the one above it, but the system actually leads to some redundancies. For instance, the lower blocks are subject to greater forces than the upper ones, but since each one is the same, they can really be tailored to the individual structural needs. But even that means you have a lot of extra structural capacity in the system, fractalizing a building to get more surfaces. So instead of having a window looking one way, you look three ways, and also fractalizing it so the roof can become a garden, adding surface insulation. Habitat is what we would call a bottom-up design strategy. That means it starts with something small, in this case a living unit, and builds up a design that makes sense from the perspective of the unit. You can identify this in the design because the end result doesn't look like anything in particular. There's no predetermined form that it should take from the outside. There is some symmetry and maybe mountain-like forms, but in general, it's a pile of blocks, and that pile is generated based on unit-to-unit relationships. This would be in contrast to a top-down design strategy. This is when you start with a predetermined form, and then the smaller elements are subservient to this larger concept. When units are crammed within a bounding box, there's an interplay and dependency between the individual units and between the units and the supporting space outside of it. Sometimes one or more of these can just get awkward in order to make way for the other. When the building is modularly pixelated, the unit dominates and makes the other spaces subservient to the module. So the leftover spaces are either straight when things line up or jagged when they don't. The units themselves stay consistent and the other spaces vary. This can be beneficial and efficient or not. And here are the trade-offs. When it is a benefit, the space on either side of the unit might be a greater outdoor space like a balcony or terrace for a gathering. This can be public or serve an individual unit. The circulation is self-evident, both vertical and horizontal. Streets. Cars, you see where they are, you know where you go, so there's a network of these net people can move through that network. This can make the units feel larger than they are, and create more connection with the surrounding city or natural elements that can grow on these surfaces. When pixels are misaligned, this module can get expressed as corners or projecting elements. This can also be both a positive or a negative. More corners means more opportunities for dynamic views out or through the building. Projecting elements can also provide shading for units below, diminishing the need for blinds or air conditioning. But it also means that you can easily find your unit within the larger structure. This can be important psychologically, as communal living can sometimes feel consuming or anonymizing. Recognizing places of collective activity is just a sense of being orientation and familiarity that gives you the sense of identity and comfort. But being able to point to your specific house identifies your individual home as a separate entity. In some ways, pixel buildings operate like small cities or neighborhoods. Then there might be pixelation and so on, and sort of the sense that it's made up of many dwellings. So, they might create the feeling of a village all by themselves, or they might connect seamlessly with the surrounding city rather than standing alone as a monumental discrete structure. The pixels also just visually break down the perceived size of the building. Instead of looking at one thing, you are seeing the expression of many little things. It might look more varied and dynamic, or even like it had grown there over time, again making it more city-like than building-like. In summary, Habitat 67 is characterized by its unique structure and design. Although it appears to be stacked concrete boxes, there is a clear order and design within. This reflects a bottom-up design strategy based on the relationships between individual units. Additionally, modular pixelation creates diverse spaces and enhances connectivity with the surrounding city or natural elements. These features transform Habitat 67 from a mere building into a city-like environment, creating a distinct and dynamic atmosphere overall. In the following video, we will delve deeper into the overall structure of Habitat 67 and how it withstands loads. Specifically, we will examine how the elevator core and corridors bind Habitat 67 together as one cohesive unit, supporting its overall structure. Then, we will explore the method of lifting modules into their respective positions and discuss the post-tensioning technique. Thank you very much for listening to our Team 7 presentation so far.